This is 3.3, the distributive property. So we can use the distributive property to simplify expressions involving variable terms and rational numbers. So the distributive property says that if I have a number on the outside of parentheses, it is going to be multiplied because there's no operation written in between. We know it's multiplying. This A would be multiplied by B, and A would be multiplied by C to get AB plus AC. And we know that these are multiplied if they are right next to each other. So whatever A is, that number would be multiplied by B and C. Sometimes they're variables, sometimes they are constants. So I'm going to simplify each expression. Here I have negative 1/2 times 8x minus 28. So this negative 1/2 is going to be multiplied by 8 over 1, but then it's also going to be multiplied negative 1/2 times negative 28. So I turned these whole numbers into fractions, and then we multiply straight across the top, straight across the bottom, so that we would get negative 8 over 2, which reduces to negative 4, and then 28 over 2, which reduces to 14, so that I have negative 4x plus 14. And this x here just gets carried down because the 1/2 does not have any variables in it. It's just there's only one x here. I'm saying I'm taking half of the 8x, and half of 8 is 4. Different signs makes a negative. Here I have 9 times negative x plus 4y, and we know that if there is no coefficient written in front of the x, it's an invisible one. So 9 times negative 1 is negative 9, and 9 times 4 is 36. And then, so this is 36y. I have negative 3 times negative 4 plus 3x plus 10. So distribute the 3 to each number, and I get 12 minus 9x minus 30. 12 and negative 30 are like terms, so I can add those together, and that would make a negative 18 when combined, minus 9x. Here I have negative 12 times 10 minus 4x minus 12, and I am going to distribute. We could distribute first, or in this case I chose to simplify and combine like terms inside parentheses, so that 10 minus 12 is negative 2, and now I'm going to distribute this 12 to each number, and then that gives 24 plus 48x. If you wanted to distribute first, you could do that, but it will still end in the same answer here. I have negative 1/3 times 6n plus 15 plus 4n. So this 1/3 on the outside is only going to be distributed to what is right next to it in the parentheses. So the 4n is not in parentheses, that's just going to stay on the outside until I have no more parentheses left. So 1/3 of 6 is 2, and 1/3 of 15 is 5, and these have different signs, so I have negative 2n plus 5 plus 4n. Now I have no parentheses, so negative 2 plus 4 is 2, and the negative 5 doesn't have any like terms, so it just stays minus 5. Over here, I have two different expressions, and only one of them has the 4 to be distributed. So I'm going to distribute here first, and have 18y minus 7, that stays the same. I just dropped parentheses. And then negative 4 times 3 over 2 is 6. 4 times 3 is 12, divided by 2 is 6. And negative 4 times negative 1 is a positive 4. Now combine like terms, and we get 12y minus 3 for our answer. A square pool has a side length of s feet. How many 1-foot square tiles does it take to tile the border of the pool? So first we're going to draw a picture, and then we are going to write an expression and simplify it. So if I have a square pool here, and I'm going to add the border of 1 foot around each of it. So I have a little 1-foot border here, 1-foot border here, and the side length of the pool is s. So then I could rewrite this, draw it again, so it's a little clearer to see. This is 1 plus 1 is 2, plus the side length of the pool, which is s. So I have short side is s, this long side here is s plus 2. So it says, what is the border? How many tiles does it take? So I have 2 times s plus 2, because there's 1, 2, and then 2 s's here to add. So then this is 2s plus 4 plus 2s. 2s plus 2s is 4s. So we think of this as 4 sides to go around, and then I would have this little corner of 1 square foot tile to link all of the edges together. So that's where this 4 comes from.